Well, we're welcoming some rain today, and so if you hear any background noise, we have a mic hooked up that picks up the background noise now, so we try to make it as quiet as possible. And we're trying to upgrade the sound, and we're trying to clean up some of the voice distortions. There's so many things going on weather-wise, it's hard to keep a 15-minute video constrained. Basically, what I want to draw your attention to first at the top of the screen is a river of water. Now, in the winter, if that pushes down lower, they'll call that the Pineapple Express, but it's just a giant vortex. You can see at the very top of your screen, at the 1 o'clock position, is the eye of this monster vortex. These vortexes, there's always 3 or 4 of them at the same time now, it seems like, in the northern hemisphere. And they drive the weather. They call it a jet stream, but it's no longer a stream. It's 3 or 4 rivers that are created by these spinning upper levels. And we were wondering if there was geoengineering going on in the southern hemisphere. You can see everything's supposed to spin opposite than the northern hemisphere. And the amazing thing is how these spherical, strong upper level lows that are supposed to be round become flattened, and they become flattened in a hurry. And I don't know, you have something that big and that monstrous, how you can flatten it without intervening. Nature likes to accommodate itself. But you see in the lower hemisphere some of the upper level lows that are undergoing distortion. Some are and some aren't, but they're spinning in the opposite direction, and they're taking water away from the equator. So now we have very strong upper level spinning vortexes that are drawing water from the equator. Some of it's going north and some of it's going south. And right about the Philippines and Indonesia, upper Indonesia, you see where the water separates, and some of it goes north and some of it goes south. And when that happens, when you pull water from the equator, you're going to create these huge, massive voids in precipitation. And you see the void right in front of you. This is more of the western southwest Pacific. And you can see a lot of things going on in this here streaming video. On the lower left, you can see a monster spinning vortex. It's driving that jet stream. Flattens out. I mean, it just flattens out. But the rate at which it drops, the rate at which that vortex pushes south, is almost matching something going on in the northern hemisphere. As the vortexes push south, so do the southern vortexes, and it's almost as if the change in the northern and southern component pushing this thing south matches what's going on in the northern hemisphere, way at the top of the globe. As you see a push to the south, it seems to be manifesting down low as well. And then here's another vortex, right, that is no longer spherical and starting to hexagonalize. And you get flat, straight edges. Why? It's meeting resistance. You can create resistance by spinning too fast, or the faster you go, the more wind in your face. But it's hard to envision the forces that are occurring that takes a round system on the left-hand side of the southern hemisphere and flattens it out, squashes it, while over just slightly more to the right, you get a spherical system that starts to have edges and shapes. It looks more like a twirling square. According to the laws of physics, that's not supposed to happen unless you intervene with a second force. This is kind of maybe what's going on in Saturn when its northern hemisphere vortex that spins at the top of its magnetic field turns into a hexagon. Normally you would say that would be defying physics. But it's not if there's an external force being applied to your system. that has to show itself and manifest itself sooner or later. Now, here's a different look later of that southern push. It's now over to the right-hand side of your screen, and it almost mimics what's going on in the upper part. But I've complained about how the GO satellite system doesn't tell you what's going on in the Atlantic, the northern Atlantic, and the eastern Atlantic. So we go to what's called Sat-24, and that's what you want to do is when you want to look at global weather, you have to go to Sat-24. And here we see monster systems again, and we pointed out some of these irregularities. You see streams of moisture going straight north. That's because of the large vortexes that are driving the weather. They're usually shaped like a question mark, but this one's flattened out again, and we've pointed this feature out in the Pacific, where it's no longer reaching down and grabbing moisture, and it's flattening out, like they're keeping the southern arm of this question mark away from the equator. And so, this is a giant vortex, and it's so giant it's creating smaller vortexes. And just like a giant tornado may have 4 or 5 smaller tornadoes circling the center, these vortexes are so large they're creating smaller vortexes that are all spinning counterclockwise. So Sat-24 will tell you what's going on in Europe or Atlantic, but it's so hard to try to get Greenland on a weather satellite. If you have a good weather satellite that shows real-time photos and video streams of what's going on in Greenland, please link me that satellite, link me that map, send it to me, post it on the thread. And here's a little more close-up of that water that's just going north, and you're talking, this thing reaches down south of Spain and slings water all the way up to Greenland. Those are huge systems. The orange and yellow glows, those are lightning strikes. So we talk about the flooding in the United States, but it's everywhere. You just type in a country, type in the word flooding, or type in the word wildfires, or type in the word drought, and you will find that everybody is getting subjected to extremes, one extreme to the other. Look at that. Wildfires hit Amazon, Brazil, Spain, France, and Turkey. Now, we all have a wildfire season, but when you start and you go and you research and you start reading, you see more and more the word apocalyptic, incredible, massive. I mean, 8,000 people evacuated from the Canary Islands. I mean, that's an island. I mean, 8,000 people being evacuated due to what? Not floods, but fire. But don't worry, those fires will eventually be put out by flooding. And you can see France, Italy, Croatia, Germany, New Zealand, US, Japan, and Siberia, Canada, Alaska, they're all on fire. And some of those places shouldn't be on fire. Siberia shouldn't be on fire. So now we're just trying to show you globally what's going on because it applies to you. Now, what's driving the weather is usually the solar system, the sun. And we've been trying to prove there's more particles in the solar system and in the corona that are affecting and have changed the solar system. But to do that, you have to have a baseline understanding of what the coronal hole streams are. Because every time there's a disturbance in our magnetic field, NASA, NOAA, Department of Commerce, I don't know why Department of Commerce is reporting on space weather. But I guess space weather, they're expecting to affect commerce. But if you read about these coronal holes, you'll see that, here, let me just read it so you have an understanding of what the coronal holes are supposed to be doing. Okay? let me just stop. I'm going to stop it from rolling and I'm going to read this. Okay. The radial dependence of density above polar coronal holes, those are the ones at the top and bottom, has been well constrained by measuring linearly polarized visible light in the corona. Remember, we talked about wavelengths of light, how you can see the wavelengths of light in between your fingers when you hold your hand up to a window. The polarized brightness is dominated by the Thomson scattering of visible light photons by free electrons. Free electrons. And thus the brightness is proportional to the total number density of electrons along the line of sight. That's why when we show you a white light telescope from Earth that looks at the corona of the sun, and all of a sudden there's a focusing cone or a disk or a branching out of the corona that is brighter, that's because of the particles. And if you're getting more visible light, then there has to be other types of photon energy being emitted too. Electrons release the entire range of radiation from visible light to infrared or from visible light to gamma radiation. The whole spectrum an electron is capable of emitting depending on its temperature, speed, and change of direction. So the electron density in coronal holes is anywhere from 3 to 10 times smaller than the electron density at corresponding distances in the coronal streamers. So the coronal streamers are those bright beams that appear to come out under white light. You see them on SOHO, white light or visible light. And it looks like laser beams coming off the sun. And basically what they're saying is above a sunspot, if there's a loop, that you can eject electrons through those loops and create these streamers where the electron density is what they say 3 to 10 times larger than the coronal hole. So the coronal hole is supposed to have fewer electrons than these active regions with loops. Okay, which is one reason why they travel faster. But listen to this. Because the coronal plasma originates in the electrically neutral gas of the photosphere, the number of, this is so important, the number of positive and negative charges must remain equal, even when the gas becomes ionized. Ionized means you get it so hot that an atom loses its electron and becomes just a nucleus. So a nucleus of a hydrogen atom is called a proton. So you're supposed to have electrons and protons in equal numbers. There it is. By the scientist, not from me, by the scientist. Thus, the electron density can be combined with this constraint, and information about the abundances of different chemical elements, notice it didn't specify, in the corona is derived from the densities of protons and other ions. So the abundance of different chemical elements in the corona, they can use that to derive the densities of protons and other ions. Now, that has gone out the window. The outflow velocity of the solar wind particles can be measured in several ways, in both the density and the cross-sectional area of the magnetic flux tubes formed by neighboring lines of magnetic force that channel the plasma. So even though the densities of ionized particles in the coronal hole streams are lower than the sunspots, there's still flux tubes that channel the electrons and actually also influences protons. So then we go to another, I hope this is visible to you. When you crop text sometimes, the text becomes blurred if you don't crop it outside the original frame. Once you stretch the letters, they start to blur. But here's something about coronal holes, and this is just going to another resource to demonstrate what I just read to you is the truth. But you can see many, many things here about the temperatures of the ions, of the electrons and the protons are supposed to be equal. That the proton and electron temperatures are always constrained to being equal because they come from the same regions of the sun. I mean, there it is right there. What that says right there that I highlighted for you, the horizontal line component to an electron flux equals that to the proton flux. So everything they measure in a coronal hole, the electrons and the protons share very similar characteristics. Temperature, concentration, and emissions. So the protons and other minor ions is everywhere equal to the density of the counterpart. So there you go. What I've been saying for 5 years is that the solar wind parameters have shifted. There's something different about the coronal hole streams. And it's not just the coronal hole streams, but you keep seeing NASA blaming coronal hole streams for our magnetic disturbances. So then we look up the components and the characteristics of coronal hole streams and what they actually are measuring, and they put it up there for you to see, is different than what's being described in the literature. But then you go to the NOAA report. The NOAA report states every week that there's low energy electrons, that these low energy electrons are fluxing at high to moderate levels, but the proton flux is always at background levels. So how do you have a high electron flux coming from a coronal hole stream with no protons? Is completely and totally impossible the way the sun works. The only thing that accounts for that change is the addition of a second solar wind that consumes protons. And that would be helium-3. Helium-3 wants to become helium-4. So when proton hits helium-3, which is really 3 protons, it wants a 4th proton. So you have an abundance of helium-3 soaking up all your protons. But meanwhile, helium does not affect electrons. In fact, helium is one of the best conductors of electricity on the planet, with almost no resistance and heating by the electrons, meaning electrons cannot heat helium. And we know this because they use helium now in giant, massive magnetic imaging devices that you use for medicine. You have an electromagnet, and the conductor of the electromagnet is not copper wire, it's helium in a tube. Why? Because no heat is generated. There's no resistance. So here we have, time and time again, we have no protons and high electrons. Something has changed. And the only people that are going to tell you about it is, well, me. Now, so you see that the electron temperatures are supposed to remain the same. Proton temperature is supposed to be equal to that of the electron temperatures. The ratio and total numbers of protons to electrons is, in fact, equal, and that the lower density of particles, the higher your speed. Well, then why all of a sudden, instead of running inverse to one another, the density and the speeds are mimicking each other? When the densities go down, the speed goes down. When the density goes up, the speed goes up. The only thing that can account for that is a second source of particles. And the bottom line is your temperature. And now, these temperatures are constrained, but they're running below average temperatures. So that tells me that these electrons are coming from somewhere else than the sun. That some of them. And you see the blurring of the green line. You see a scattering in terms of temperature. This isn't very obvious. There's other this instrument. There's other temperature readings that show greater scattering than I'm showing you now. I have to hunt them down and go through each and every one. But when you have such an array of temperatures above and below this line, 10 to the minus or 1 to the minus 5 on the E temperatures, then my goodness, what's accounting for such a spread in temperature is more than one source of particles. So then where's all this extra stuff coming from? And when somebody makes an excuse for what happening, and it comes from an official source, government, then when they make an excuse for something, they've admitted its existence. And this is what I love. Even though they mislead you on the explanation, when they give you an explanation for something, that means there really is something going on. That means there's something there. People denied that the volcanism was increasing for 3 or 4 years. And then all of a sudden an article came out blaming the sun for the volcanism. So even if it's right or wrong, the minute they blame the sun for the volcanism, they're admitting there's more volcanism. But we think that the helium, and we know it's to be true, NASA has been on the search for Planet X and Nemesis ever since Percival Lowell discovered Pluto. Articles exist left and right, hundreds of research articles trying to locate and find Nemesis. Nemesis and Planet X are terms that were made up by astronomers, not conspiracy theorists. But if, in fact, a large object was out there, large enough to create cyclical extinctions, large enough to change our own sun and change all the planets in the solar system, to throw off our magnetics and our orbits and our location and our orientation around the sun, then this thing should be slinging debris everywhere throughout the solar system that eventually will be captured by the sun and brought back in from all different sides of the solar system. But the highest density of debris should be coming directly from and off that object's location. And so we have to look for debris in our solar system. And in 2011, 2012, 2013, and 2014, even before then, 2009, 2008, 2010, we were seeing incredible comet numbers. More and more comets flowing into our solar system. How many comets, new comets, have we suddenly discovered? Thousands. Thousands. We showed you the database with like 2,800 new comets in just from 2009 to like 2012 or 2013. Thousands of new comets. Well, why do they show, if there's such a long period comet, why are they clustering? When you have something that doesn't come into the solar system for every 1,400, 1,500 years on that kind of orbit, then how come they're showing up in clusters and so close to one another? That's because they're new comets. They're newly created, newly pulled in, newly slung into our solar system comets. They're new. And along with that comes, after the comets started showing up, what else? Fireballs. breaking the sound barrier, meteorites impacting Earth. There's been over 20 plus confirmed meteorite impacts since 2009. And they're all small, and most of them are in the ocean. And we showed you an article from NASA astronauts talking about the asteroids that are coming into our solar system. So now we go to see if there's any changes in our magnetosphere. And we use the magnetosphere to try to determine the position of this brown dwarf. The reason we know it's a brown dwarf is because all the helium and lithium that's in our solar system. Lithium is a conclusive determinant in finding out if something is related to a brown dwarf. Brown dwarfs are loaded with lithium from the decay of beryllium. And it's not so hot that the lithium decays into helium. So at least not all of the lithium. So I want you to look at the lower left magnetosphere. The lower left magnetosphere shows you those blue vertical lines, which are magnetic field lines that are created by the electrons flowing past the Earth. And we see particle densities coming in, but sometimes they come in and they do not compress the magnetosphere. So when you don't compress your magnetosphere with particles, usually that means they're electrons, or they're slow moving, or they're low density. But when you pick them up on a density meter, you can't really call them low density now, can you? But those magnetic field lines on the lower left, they're not even moving until a wave of particles washes through. They're almost stationary. Now, we theorize we're passing right between the brown dwarf and the sun right now. We're going to be doing that. So that on the simulations, the brown dwarf is off to the left now. And what that should account for then is slower wind speeds coming off the sun, because they're going to run somewhat oppositional to this brown dwarf. And you're going to see magnetic field lines going in the wrong direction because there's electrons coming from the wrong direction. We go up to the right, the upper right, and you see a constant presence of backside energy. Remember, what releases the most energy are electrons. So you see this background energy. Sometimes it looks like a focusing cone of electrons coming from the right, but there's a penetration from the left. So if we're passing in between a brown dwarf and the sun, we should be getting electrons coming in our backside, and there should always be a present there. That would account for the stalling out of those magnetic field lines. That would account for that. And there's just a constant presence, and a large presence. And it's not associated with the arrival of solar wind coming from the right-hand side, because it's there whether or not there's particles washing through or not. Then we go up to the upper left, and if there's wind coming from the left, those vectors right there in that flux tube should want to always point at Earth. And there they are, pointing at Earth. Even when you see ejections of particles, look at that, being ejected out of our tailstream, there's still always a presence of arrows pointing at the Earth, because they're pointing away from the brown dwarfs. So there's particles coming from the left. And it's not particles that are being refocused by the Earth's gravitational field, because you can see the V right there, that's a split. That happens when a wave of particles shaped like a comma or a crescent comes in contact with a second source of particles. It splits. It splits that wind into two components. And you'll see more than one example of that V shape being created in the solar wind. And we did have a coronal hole stream come through, and you can see the magnetosphere compress and increase inward. And that's what's created by stuff coming off the sun. So, to wrap it up then, we have increased energy coming from a brown dwarf. based upon the solar wind, and there'll be earthquakes too that'll verify this, and they should be starting pretty quickly, and it should last about 10 days, and it should approach 7.0 magnitude. And if Jupiter gets involved or Venus gets involved, then you could expect high sevens. But this brown dwarf, pretty soon, when you study these instruments and you research solar and wind parameters, this obvious stares you in the face. So the question is you can't do anything about what this brown dwarf does, but you can protect yourself from the radiation. You can, and I was informed that we have a subscriber who's paying $50 a month on Patreon, and we were supposed to send him some chlorophyll. We're going to double and triple that chlorophyll and send it to the man. Now, he's Hispanic. I don't think he needs an artificial tan that blocks out solar radiation. I don't think he wants to be darker. So we're gonna just replace that tanning gel with more chlorophyll. And Mr. Ochoa, I'm terribly sorry that our channel was fractured and fragmented, and I was displaced, and our equipment was displaced, and some of the stuff is in storage. And yeah, I'm just really sorry. And if our channel seems like a joke, Mr. Ochoa, it's because life is a joke. But things are falling into place. So basically what's happening then is you're having more radiation in the solar system and in the magnetospheres of all the planets, but mostly in the corona of the sun. That is sucking in all these particles. And you can go back and look at the patterns. And when we passed into the pocket, there was almost no particles. There was almost no geomagnetic storms. A pocket's created. It's like a little void. When a giant boulder is in a fast-moving stream, you get behind the boulder. There's a void in the stream. But then when you come out from behind that boulder, you run into a wave of particles. We ran into that wave of particles. And all of a sudden, the wind speed started to increase. The temperature started to increase. And guess what? That's because we were passing through stuff that was ionized. And now we shouldn't be getting the high speeds of 600 to 650 kilometers a second, 750 kilometers a second. I mean, some of those coronal hole streams, ladies and gentlemen, leave the sun at 1,000 kilometers a second. By the time they reach us, 350, 450, 500 kilometers a second is not very fast for a coronal hole stream. So the slower wind is because there's so many other particles in the solar system that everything coming off the sun is meeting resistance. Unfortunately, you have particle collision and particle exchange that creates radiation just in the backgrounds of the solar system, but also coming off the corona and being generated in our own magnetosphere. So you can protect yourself from all that. You can insulate your windows. You can not go out in direct sunlight and get additional photon energy. And a lot of these particles that get through are not ionized. So the helium getting through is not as radioactive as protons, alpha particles, and electrons. The helium that gets through, because it's neutral and magnetism doesn't affect it, is hot. It's warm. It's heating the troposphere. Now people say, well, the ionosphere isn't heating, therefore something's wrong. Yeah, because the ionosphere is not heating, the oceans aren't heating. Even though the instruments say you're wrong. And if you fly an airplane and you fly an airplane in bad weather and you operate on what you see and you don't go by what your instruments are telling you, you're going to crash. You're going to crash. And the thing too is that when you ignore the temperature of your oceans, you're basically becoming an illiterate. You're becoming an idiot. Because nobody ignores what's going on in the ocean if it's affecting the globe, and it's affecting weather, and it's affecting fires, and it's affecting the heat, and it's affecting everything that goes on around you, why would you just disregard? Now, the ionosphere is prone to radiating heat out into the space. The ionosphere is a transition zone where the heat just goes, it gets sucked up, and so there really shouldn't be a whole lot of heating in the ionosphere. But when you go and you measure alpha particles, and you measure neutrons, and you measure electrons, and you measure particles that are radioactive in the ionosphere, we're seeing an increase there as well. So, you can ignore what temperature increase, something taking the temperature of the ionosphere, and, that wouldn't be helpful, but it'd be even more destructive to ignore the number of particles they're measuring and ignore the temperature of your ocean. Now, if the oceans were getting warmer, you would know it. The tidal pools, especially if it's because of the sun, the tidal pools would heat up. And they have. And if you go look at your tidal pools, there's nothing living in there except purple-colored, tinted sea anemones. They're doing better. They have something that absorbs UV. That color tint is helpful. It's like a chlorophyll. But the white sea anemones, they look sick, and many of them aren't even around anymore. There's no starfish. There's no little fish. There's just these purple tinted sea anemones. So that would be like supported by the oceanic temperatures. And then they hear about all these die-offs created by red tides, red, blue-green, and blue-green algae, cyanobacteria. I mean, those things are toxic to all animals.